Hey everybody, welcome back to CSE 1322. This is module number 2. Today we're going to talk about methods in Java. So in your previous class you dealt with Python and you were looking at functions in Python. And a function is a way of putting a block of code together, giving it a name and making it reusable so that you can reuse it over and over again. A method in Java is pretty much the same idea. So a method is effectively like a black box. It has some input where you can send things into it, it has some output where it sends something back, and then the details of how it goes about doing that are written in the method body. And so what you can think about with a method is it's effectively a way of taking a block of code that you're going to use over and over again, writing it once and giving it a name, and then you're able to call it. As a matter of fact, you're used to the idea of there being methods because you use them all the time when you're in Python. So one example of that is when you were trying to find the average of a list. There was an average function that you could use, or the minimum number in the list, or the maximum. Those are all methods, or functions as you call them in Python, that take in a list, they find the thing that you're looking for in the list, and then they return that back to you. So it's a block of code that can execute as a single entity. So think of them as a black box, take in some parameters, that's what we call the inputs, and they have a return type, which is what returns the answer back from the method. So again, in Java, methods do the same thing as functions in Python. You'll hear these referred to as different things in different languages. Some people call them methods, some people call them functions, some people will call them procedures, but they all do pretty much the same thing. Alright, so in Java, if you want to declare a method, the way that you do that is you first have to specify the return type. So the first thing to notice here is notice there's no def keyword. So in Python you were used to saying def and then the name of the function that you were trying to declare. Here there's no def keyword. It understands that you're declaring a method based on the way that it's written. And so you're going to have this return type, the name of the method, and then any parameters that are inside of parentheses. And then you'll have curly braces because most everything in Java has the curly braces around it with the body of the method inside there. That's the actual code that you want it to execute. So let's take a look at that top line again just for a few moments. So as we said, the first thing you're going to have is you're going to have some modifiers. In Java, it's possible to declare a method as public, private, or protected. We're going to talk about that in detail later on, but for now, pretty much every time you write a method, you're just going to say public to start off with. The second keyword that's in here is the word static, and this is again a modifier that's used some of the times. If you're declaring a method inside of your main class, then you're going to use static. If it's in another class, you're generally not going to use static. So again, don't worry about the details of that for now. Generally, when you're going to be writing methods, it's going to be in a single class for now, and so you're going to say public static inside of your main class to begin. Then you have the return type. This can be any type that Java supports. So we've already seen the primitive types of ints and floats, longs, doubles, bytes, shorts, chars, and booleans. So those return types can be in here, but it can also be a complex type. So you could have a string in here, a list, an array, or an array list are other options. You can also have your own types that you're going to declare later on as the return type. Then you have the method name, which this should be something that's descriptive and talks about what the method does. In this case, it adds two numbers, so we called it add two numbers. You'll notice the way that this is written is in what's called camel case, and most things that you write in Java are going to be in camel case. If you have more than one word, the first word begins with a lowercase letter, and then all the subsequent words begin with uppercase letters. A rule for a method name is that it cannot have any spaces in it. So if you're going to have more than one word in there, which you're often going to want to do because add two numbers is obviously three words, you're going to say add two numbers all squished together with the capital letters on the second and third word. After that name of the method, you're going to have a set of parentheses. Those parentheses are non-negotiable, they have to be there. It's actually how Java realizes that you're declaring a method. Inside of those parentheses is whatever parameters that you want to pass into the method. In this case, this method is going to take in two parameters, one that is called x, which is an integer, and one that is called y, which is also an integer. Again, this is different than what you were doing in Python. There was no type in Python because, again, Python doesn't care most of the time. It can figure it out from context. But in Java, strongly typed, you have to specify which type you are expecting that parameter to be. So this takes in two integers, and apparently it adds them together. The way it's doing that is in the body of the method, which is down here between these curly braces. You can see we're returning x plus y, which is the x that came in and the y. They're being added together and returned. So if you wanted to use this down in your main method, you would do something like int result is equal to add two numbers 5 and 2. So these are technically called the formal parameters, and these are called the actual parameters, or more commonly the arguments. So these are the arguments that you're sending to this method. You can reuse this method over and over again. I can say add two numbers 10 and 15, add two numbers 142 and 757, and it will return the answer in all of those cases, and I'm storing that answer over here in result. So the way you call a method is simply by specifying the name of the method, open parenthesis, and then you have a set of parameters that must match the formal parameters in the definition of the method, in this case 2 integers. If I were to put a period in here, like 2.3, it won't compile because this is no longer a integer, it's now a double or a float, and that doesn't match the formal parameter list. So be careful when you call it that you're passing it the right types of parameters. All right, so next up we're going to talk about the return type of the method. So as I mentioned before, each method has a return type which is specified in the header, and so that return type can be any of the variables, any of the types that Java supports, any of the primitive types or complex types. Once you specify that a method has a return type, you must match that return type at some point in the method. So if we were to go back to our previous call here, our previous method, you'll notice that our formal parameters took in an x and a y, and we mentioned that they have to match. But our return type for this method said that it was going to return an integer. And so we did that by returning x plus y. Had we not returned x plus y, then this method wouldn't compile. I have to return something that's an integer. Now, if I did x minus y, it would have compiled. If I just did x, it would have compiled. It wouldn't have been giving me the right answer for adding two numbers, but it would have at least compiled. The requirement is once you say that it's returning an int, you must return an int. If you try to return a string, it doesn't compile. If you try to return a boolean, it doesn't compile. It has to be an integer. So in this case, our return statement here is what's returning x plus y, and that indeed is an int. So, as we said, the return statement that you saw in there actually has two purposes. The first purpose is that it halts execution of the method immediately. So what does that mean? Well, if you had code in here before this return statement, so remember there can be more than one line between these curly braces. If you had code in here before this return statement, obviously it will execute from the top down, and then when it hits the return statement, it immediately ends the method. So add two numbers ends the moment it hits that return statement. That's the first purpose of a return statement. It stops execution. And just to be clear, if there were code below this return statement, it probably would give you a compiler warning to start off with and say there's unreachable code because it knows it can never execute anything past this return statement. But presuming that the return statement's in an if or something like that, then it may allow you to compile it. It's just never going to get to those other statements if that return statement ever executes. So again, the first thing that a return statement does is it stops execution of the method, and then the second thing that it does is if there is a parameter after the return statement, like there is here, it actually returns that value back from the method. And so in this case, it returns the sum of x plus y. All right, so what happens if you have a method that isn't going to return anything, something that perhaps just prints out some text? Well, in that case, you would specify that the method has a void return type. So void means it's not going to return anything. And once you specify that it's a void return type, you can no longer return a value out of the method. You can still have a return statement, but you can't have a value after the return statement. So what I mean by that is, if the method is a void method, it returns void, then you can say return semicolon, and that will end the execution of the method. But you cannot say return 7 because you've specified the method returns void, and now you're trying to return a 7, which makes no sense, so it won't let you do that. So whatever expression that you have in here, it must conform to the return type. If it's an int, it must be an int. If it's a car, it must be a car. If it's a string, it must be a string. If it's a dog, it must be a dog. But if it's a void, then the expression must not be there, and you just do return semicolon. All right, so that brings us to the names of the methods. As I said before, it is very important that you name your method appropriately. Don't just name it with some name because you have to, like X or Y. Always name the method something that makes sense. I said this exact same thing when we were talking about naming variables. And again, this is something everybody does. You start off and you make a bunch of variables and you're like, oh, I don't know what to call it, X, Y, Z. As a matter of fact, a lot of people tell me this is the hardest part of coding, is figuring out what to name all your variables and all your methods, which makes no sense, but it really is important that you get used to naming things what they're doing. Again, if you're writing 5 lines of code, it doesn't matter, but you're not going to be writing 5 lines of code. You're going to have millions of lines of code that you're managing. So it's important that you name things appropriately in a way that people can find them. So a method that's going to find the smallest number in an array, you'd probably call it find smallest, and it takes in an array. All right, so inside of those parentheses at the top of the method header, you can have 0 or more parameters. It's absolutely possible to write a method that doesn't take in any parameters. For example, if you have a method that just prints a greeting on the screen, there's no parameters. You just print the greeting and life is good. But if you want the method to allow you to optionally specify the name of the person it's greeting, then you're going to need to take in a string that is the name and allow that to be printed on the screen. So a method can have 0 or more parameters. No matter what, though, the parentheses are not optional. They have to be there. So when you say public static void do things, there has to be parentheses after do things. Each parameter that you have in there must have a name and a type. The type comes first, the name comes second. So you're going to say int x or string name or boolean is true, whatever it might be. The type you pass must match those types. I've said that before. The name can be anything, but again, you should be naming things so that they make sense relative to what they are actually doing. So make sure you're naming your parameters appropriately. All right, so here's an example, a method to find the length of a name. This one takes in a name, so it's string, and we called it the name, which is not very creative, but it is very descriptive. The name of this method is name size because it's calculating the size of the name, and it is going to return an int. You'll notice this one is public, and as I said, almost always you're going to put public there to start with. If you forget to put public, Java will automatically assume that it's public. Java assumes everything is public unless you specify otherwise. And again, we'll talk about what that means later on. And then what we're returning here is the name.length. So the name is a string, and strings have a method called length, as we talked about in one of the previous videos. And so the name.length returns the length of that string. This method returns an int because that's what string.length actually calculates for you. It gives you a number, which is the number of characters in a string. I certainly didn't drop a pen there. All right, so let's go ahead and put that in here. So we have public. I'm going to add in the word static because I'm doing it in main. It's int, and it is name size, which takes in a string called the name. I need curly braces there to specify the beginning and the end of my method. And simply what I'm returning is the name.length. All right, so down in my main method, I'm going to create a string, name equals enda, and I'm going to print out name size of name. Okay, now I'm doing a lot of stuff there in one sentence. I certainly could, or in one line. I certainly could have broken this out into two things. I could have said int size is equal to name size name, and that would have taken care of the part that's in parentheses here. I could now replace that by simply the word size. So let me go ahead and do that. So it works either way. All of those are valid statements. And let's go ahead and run this. And what we would expect is that it's going to tell me that the size of that name is 4. And indeed, there is the 4 over there on the left side. If I give it a longer name, we would expect that it's going to give us back something that is longer. 13. Apparently there's 13 characters in there. Okay, so we've built our first method. It just does one thing. I'd like to point out that a method often will have more than one line in it. And so certainly there's no reason why you can't have more code right here where the cursor is. The return statement generally is going to be the last thing that you put into the method, because once it hits that return statement, the method ends. All right, so moving on again. So let's talk about the difference between Python methods and Java methods. In Python, you always began with def because you were defining a function. And in Java, we don't do that. We just simply have no keyword for defining a method. You just define the method. The second thing is that in Python, each of your parameters was just specified as a parameter with a name. It didn't have a type, and it could have a default value. So you could say name equals and then some value inside of the parentheses. You cannot do name equals in Java. There is no ability to do default values in Java. There is a different way to do that, which we'll talk about here in a moment. But parameters in Python could have default values. In Java, they cannot have default values. In Python, you could have a return keyword. In Java, you can have a return keyword as well. If you have a method that has declared as returning a type, you must have a return method inside of Java. If it's returning void, the return statement is optional. It can be there, but it can't have any parameters. All right, and so other things to talk about on the Java side. You must always return the data type that is specified in the method's header. So if it says it's returning an int, you must return an int. Generally, your methods are going to be public. Sometimes they'll be private, but almost always they'll be public. For now, just assume it's always public, and we'll talk about that later. You must declare what data type they're returning. It can be void, but there has to be a data type specified, which is either a data type or void as the return type. Methods inside of the driver class, i.e. the class that you are building, your first class effectively. Let's take a look at this. So this is my Java code, and you'll notice that I'm building all of this method and these lines of code inside of a class called main. So that is my driver class. Driver is just a fancy word for the main class, the class that has main in it. Every time that you have a Java program, when we talked about this in the past, we mentioned that there's a skeleton, and part of the skeleton is you have to have a public class name, and it can be main, it can be whatever, and then you must have a public static void main, which is your actual beginning of the code. The code starts here and executes, and at this point it breaks up to here and runs this code because that's what this name size calls. So what we're talking about here is that the main class, which is the one that I'm using to hold my code, that is going to have everything specified as static. If you declare a new class, which we'll talk about how to do that in the next video, but if you declare a new class, then the methods inside of that new class will not have the static keyword. And again, we'll explain all of this later on, but for now, you're going to get used to public static, and then the type, the name, the parameters, and a set of curly braces. That's how you declare a method. All right, and the last comment here is that methods can be overloaded. We're going to talk about that later on in this video. All right, so let's talk about indentation inside of our parameter, or inside of our methods. So here was some Python code. We said def adder, and it took in A and B, and it returned A and B. The equivalent code in Python here is public static int adder, int A, int B, and it returns A plus B. So it's very similar. It's just that we have to have this int, and we have to have a return type inside of Java because everything is strongly typed. But other than that, it pretty much is a similar thing. So the first thing to talk about here is the indentation. In Python, you had to indent one tab, or at least a space, in order for it to be clear that this return statement is inside of the definition of this method. Java uses curly braces to do that same thing, but you'll notice that I still indented the code, and that's because the indentation is very useful. It makes it very clear, that this return statement is inside of that method. Even though there's curly braces that are very clearly specifying what's inside of it, the indentation makes it easier to read. Without this indentation, this code will work just the same. And so let me just prove this up here. I'm going to go to this. I'm going to actually just put all of this on one line. That's the same method, but it's now on one line. I'm going to run it, and you'll notice that it still returned 13. It doesn't care that it's all on one line. It's happy to execute it. And I could do the same thing with main down here, And that's all perfectly fine to the compiler as well. However, you as a human, you look at this is suddenly a lot less readable. It's like, what's happening here? And it's because you've lost all of the formatting of what's going on. So you should never do this. Yes, it's technically possible, but you should always indent everything just like you used to do when you were in Python. So the general rule is if something is inside of something else, you're going to indent it, and then you're going to line up the closing curly brace with whatever it is that you opened. This makes your code way more readable, way more understandable to a human. And again, I know you're thinking, but the code is 4 lines, I don't care, it works. I don't want to be bothered with this. Well, great, you're never going to be a software engineer. Because the reality is, you're not dealing with 4 lines of code, you're going to be dealing with a lot of code. And it's important that your code is readable by you and also by other people. So keep doing the indentation, even though it's technically no longer required. Alright, so return types and parameter types are enforced. I've said this many times, but let's take another example. So here's a method that's called greater than 0, which expects an int to be passed in, and it returns a string, and that string is going to either say yes, it's greater than 0, or no, it's not greater than 0. Okay, so what is going on here? These parameter types are enforced. If I try to pass the string hello, it's not going to work. And what I mean by that is if I were to say greater than 0, parenthesis, hello, it's not going to work. And I can prove this over here in my existing code. This method nameSize is expecting a string. Let's watch what happens when I put a number in there. And I try to run it. Immediately, it underlined the 10, and when I try to run it, it says incompatible types, int cannot be converted to a string. Now, why is it trying to convert into a string? Well, it's saying that on line 10, that's where that is right there, it got an int that it's going to have to convert to a string. And it's because the name is a string. You can see the compiler, or actually the IDE here, put in the word the name. That's because it realizes the parameter is called the name. And it knows it's supposed to be a string, but what I actually gave it was a number, and it can't convert that number to a string, therefore it's not going to work. There is no way to make this work. Java is strongly typed. When you say you're going to send it a string, you must send it a string. Once you do that, it's happy with it, and it will work. Alright, the same thing is true for the return type. If you specify that it's going to return a string, and in here you try to return an integer, it's not going to work. Alright, the void return type that we've mentioned. A return type of void means the method will not return anything. So here we have public static void greater than 0, and it's void this time. That's because we're doing some print statements in here, and we're just printing out whether it's greater than or less than a. This code is very similar to the last code, so let me go back over here. In the last code we returned a string. Notice that I actually have a return statement and then there's a string. In the new code, I'm not doing a return statement, I'm doing a print statement. So notice that a print statement doesn't count as a return from a method. That's a completely separate thing. I'm just printing something on the screen. In this case, I cannot return anything because I've specified this method returns void. So I can have a return statement, but it must simply be return semicolon. It can't be return a is greater than 0 or return 7 or return false. It has to be just return semicolon because of this void right here in the header. So here's an example with a return keyword just being used to end the method. And so here we have public static void greater than 0. It takes in a range and an input, both of which are ints. And it says for I equals 0, I less than the range, I plus plus. So this is a for loop that's going to count however many times you put in range. So if range is 10, it's going to run 10 times. If range is 2, it's going to run 2 times. It prints out I, so it's going to print out 0, 1, 2, 3, up to whatever. And then if I is equal to the input, it immediately ends. So for example, if I were to pass this 10 and the number 3, once it gets to 3, it's going to stop. Alright, so let's take this and let's actually add this method. So we have public static, this is a void greater than 0. It takes in an int range and an int input. Alright, and it says for int I equals 0, I less than range, I plus plus, and then inside of here it prints out the number, I, and then it says if I is equal to the range, return. Alright, so let's play with this for a moment. Down here in my main, I'm going to make a call to greater than 0. I'm going to pass it 10 and 3. So when I run this, I'm also going to turn off these earlier things. I'm just going to comment them out by putting 2 slashes on front of each of them. Otherwise, we're going to get that rogue 13 that it's, or the 4, I guess, that it's going to print because of the size of enda. Okay, so I don't know why I said I equal to range. I meant to say I equal to input. That's the other parameter. Sorry, typo on that. All right, so running it, we see we get 0, 1, 2, 3. And that's because this for loop by itself would have run till 10, because the first parameter I passed it, range, is equal to 10. So it says I equals 0, I less than 10, I plus plus. So normally this would have run to 10, and I'm going to prove that by commenting out this if statement. So now that if statement's not going to run because I've made it into comments, when I run this code, I'm now going to get 0 through 9. And that is 10 numbers because 0 is counted. All right? So now I'm going to put this if statement back in again, and we're going to talk about what this if statement is doing. If I is equal to the input, which in this case is 3, then return. And remember what I said, return is allowed here even though this is a void because there is nothing after it. I can't say return I can't say return input, I can't say return enda is the coolest constructor ever, I can just say return semicolon. That is what's going to end the method. So when I get to 3, when I is equal to 3, this return exits the method. And that means that the for loop and everything that was running in this method stops immediately. That's what a return statement does. It immediately ends the execution of the method. Okay, so let's take a look at the parameters that are coming into a method. The number, type, and order of the arguments must match the parameters in the method. So in this example here, we're taking in one parameter. It happens to be an integer. So therefore, when we call isPositive, what we must send it is one parameter. It must be an integer. But the order also matters of the parameters. So if we had a method that takes in 2 parameters or 3 parameters, and the first one's an int and the second one's a string, when we call it, when we're down in main and we're making a call to that method, we must specify the same number of parameters in the same order. So it's very important. That's how it actually knows which goes to where. If you think about one of the previous examples where we had 2 parameters going into a method and it was adding them together, like this one, it doesn't really matter because it would work either way, but how does it know which number went to A and which number went to B? And the answer is it knows it based on the order of the parameters that you passed. So if you pass 7 and 3, you'll get 10. Now granted, if you pass 3 and 7, you'll still get 10, but that's just because of adding. If you do something else with them, if you're checking them in some other way, then it won't work. All right, so let's write a quick example over here. So what I'm going to do is I'm going to write a method. So we're going to start off with public static, and it's going to return an integer when I'm done. And what we're going to do is we're going to count vowels. All right, and it's going to take in a string, which is a name. It's going to tell me how many vowels are in that name. So let's talk about how we would go about doing this for a moment. So down in main, what we're going to do is we're going to have a string name equals enda. We'll go ahead and do enda Sullivan. And then we're eventually going to call count vowels, and we're going to pass it that name, and it's going to return to me num vowels, which is the number of vowels, which I'm going to print out. All right, so that just prints out how many vowels we have. All right, so how would we count how many vowels we have? Well, the way we're going to do this is we're going to take the string and we're going to have to break it up into smaller chunks. And then each chunk is going to be one letter. And then we're going to compare that letter to A, E, I, O, and U and tell us whether it's a vowel or not. So in order to do that, I'm going to have to take the string and break it up into a smaller chunk. And so using a board here, let me show you what I mean by that. So initially we're getting past enda, and let's just leave it as enda. That's our string that's coming in. So what I need to do is I need to make an array And much like a list in our Python class, and an array has 0, 1, 2, and 3 cells. And into the first cell, I'm going to put an E, into the second cell, an N, third cell, an A, and the fourth cell, a D, and then an A. And then I'm going to go through each cell, and I'm going to say, is that a vowel? Is that a vowel? Is that a vowel? Is that a vowel? And I'm just going to count, keeping track of my count over here, which is going to start off as 0, and each time I see a vowel, like that one, I'm going to change it to 1, and then when I see another vowel, I'm going to change it to 2, and then at the end, I'm going to return that. Okay, so that's the plan of what I'm going to do. Let's go ahead and actually write some code on that. So we have an int count, which we're going to set equal to 0, and at the very end, I'm going to return that count. Alright, so right now it would always return 0. So then what I'm going to do is I'm going to have to convert, as we did in the picture here, I'm going to have to convert the string that I'm passed in into this array that I have of characters. So I'm going to need an array of characters, and I do that by, say, char, and then square brackets to make the array. I'm going to call it letters, because that's what it is. It's the letters in the name. And I'm going to say that's equal to the name dot, and there's a handy function here in Java called toCharArray, which will convert a string into a character array. So name.toCharArray. All right, now you might say, wait, how do you know that there's a method called toCharArray? How could you possibly remember that? Well, I didn't. If I'm being honest, all I did was I typed the name of the string, and then I hit a period. And as soon as I hit a period, what happened is my IDE automatically gave me the list of every possible method that you can do on a string. And one of them is toCharArray. It's in here. Another one is called toLowerCase, and I'm actually going to need that as well, which we're going to see that in a minute, but we'll come back to that. All right, so that gave me an array of characters called letters. And in each one, just like in my picture here, each one of them has one single letter in it. So now I can compare those letters. So I need a for loop, or maybe a for each loop. We'll use a for each loop because that's what you're used to in Python. So I'm going to say for char one letter in letters. That's how you do a for each loop here in Java. And so what this is I'm going to call each one of the letters one letter, and I'm getting them out of the collection, which is called letters, which is that array from the previous line. And so I'm just going to simply have an if statement. I'm going to say if one letter is equal to A. Now there's a couple of possibilities. It could also be one letter is equal to E. It could also be one letter is equal to I. Each of these thing that I'm putting in the middle is an or. So I'm saying if one letter is A, or one letter is E, or one letter is I, or one letter is O, or one letter is U. Okay, now notice a couple of things about what I've done. Each time I type in one character, I have to put single quotes around it. That's the rule in Java. If it's a character, like literally a car, then it has to have one quote around it. If it's a string, then it has to have double quotes around it, like I did down here. The second thing is, if statements in Java always must have a surrounding set of parentheses. It's unhappy with all of this because it sees the opening parenthesis there, and it sees the closing one there, so it assumes that's the end of the if. So in order to fix that, I need to put another set of parentheses around the whole thing. And now you can see it's happy. This outer parenthesis is corresponding to the opening parenthesis at the beginning. So if one letter is A or one letter is E, I, O, or U, then my count needs to go up by 1. Remember, you got this little shortcut for count plus plus. Okay, and that gave me back a count. So let's run this. And we have Enda Sullivan. And so the vowels are, over here we have an E, we have an A, we have a U, excuse me, we have an I, and we have an A here. So it seems to me like we should have 5. The E, 2, 3, 4, 5. But it says we have 4. And the reason is because this very first vowel, this capital E, doesn't match. I'm not looking for a lowercase e, I am looking for a lowercase e, but in actuality, what it is got is a capital E. So how do we fix that? Well, we're going to have to convert all the letters in here to lowercase letters before we start. So what I'm going to do is I'm going to make a new string. I'm going to call it lower name, and I'm going to set it equal to name dot, and again, remember that we have this to lowercase. You'll notice that the IDE put that right at the top because it actually knew that that's probably what I was going to do, just based on the variable names. Since I named my variables reasonably, the IDE was able to figure out what it was that I was trying to do. So now instead of name.toChar I need to do lower name, which is the one that's all lowercase. I'm going to run it again, and this time instead of 4 vowels, you're going to see I now have 5 vowels, and that's what I would have expected. Okay, so cool little method that checks how many vowels we have in a string. What happens if I wanted it to tell me how many consonants are in the string as well? Well, I could certainly write another method. I could copy all of this, and I could make a method called count consonants, and then it would simply only increment count if this was not true. So let's do that real quick, and then we're going to talk about how we might be able to combine them. So what I did was I just copied this whole method again and pasted it in. It's very unhappy because you're not allowed to have the same method with the same name and the same parameters twice. So I'm going to change the name to consonant, count consonants. Alright, so now it's happy with it, but it's doing the exact same thing, which is not what we want. So what I could do is, I don't want to do a count plus plus if that is equal to all of these, so there's two ways I could do it. I could change each of these to not A and not E, but that doesn't really work. So if it's not A or it's not E, well, O is not A or it's not E, but so is A. A is not A is false, but A is not E is true, so therefore that would still be true. So that doesn't work. If I'm going to change these to not equals, then I'd have to also change all the ors to ands. So if the letter is not A, and the letter is not E, and the letter is not I, and the letter is not O, and the letter is not U, then add 1 to the count. That would correctly work. So one possible way to do this is switch all the ors to ands. There's actually a mathematical name for that. And change all the equals to not equals. And this would certainly work. That will give me a count of consonants. So now I'm going to call it down here. So num vowels, I'm going to have num consonants. And count consonants. I will tell you that I can't spell consonants, that's why I'm typing so slowly. Alright, so you have this many vowels, and you have plus num consonants. Consonants. Alright, so we're going to run it again. And it tells me you have 5 vowels and 8 consonants. Now we originally saw that this name has 13 characters. 5 and 8 is 13, so that seems like that all makes sense. So my count consonants is definitely working. Okay, so I made one method that counts vowels, I made another method that counts consonants, and that all works correctly. It just took a little bit of work in here to do this. There were a couple of other ways I could have solved this that were probably a little easier. I'm going to comment that out because that's one way to do it. If I put all these back to equal equals, and I do an OR like it was originally, the other thing I could do is I could just change where I do the count plus plus into an else. So I'm putting all these back to the way they were. Alright, so that's the original statement. This, the letters A or the letters E or the letters I. And now I can do else count plus plus. Now when I delete this out, it's going to be a little grumpy about the fact that there's nothing in that if statement, but it will allow it, and it ran it, and this looks kind of goofy. So I don't know which of those is cleaner. This is probably cleaner, but you certainly could do it either way. Okay, but the question was, could I combine these two methods, since they're so very, very similar, into a single method? So I'm going to change this method from count vowels to count vowels or consonants. And I'm going to add a second parameter in here, which is called vowels, which is going to be a Boolean. Okay, so I'm going to get rid of this count consonants because I don't need it anymore. So I'm just deleting those lines down there. So we're back to one method again, but now you'll notice that it's unhappy down in main because I'm calling count consonants, which doesn't exist, so let me get rid of that. I'm calling count vowels, and I'm going to need to put in the rest of the name, so it has to match or consonants. But now you'll notice that it's unhappy with the parameters, and that's the point of this whole talk. This method now takes in two parameters. The formal parameter list says it needs to get a name, which is a string, and it needs to get a vowels, which is a boolean. And if I only have a name like I do here, you notice that it's suggesting, well, that there needs to be something for the boolean vowel. So I'm going to put in false. Alright, so I'm passing in the word false. So that means I want it to count consonants. So how do we make that happen? So inside of my if statement here, I'm going to add another if. I'm going to say if vowels is equal to true, then we're going to count here. Otherwise, we're going to count, else if vowels equals false, we're going to count out here. Okay, so to be clear, if I get an A, an E, an I, an O, or a U, and you're asking for vowels, then I'm going to add one to the count. But if I get an A, E, I, O, U, and you're asking for consonants, meaning this is false, then I'm not going to add one to the count here. I'm going to do that instead down at the bottom, where if it's an A, E, I, O, or U, or if it's not an A, E, I, O, or U, and you're asking for vowels to be false, then I'm going to add one to the count down there. Alright, now the problem here is I'm printing out how many consonants I have and I'm printing out how many vowels. So now in order to make this work, I need a num consonants, which is equal to the same thing with vowels set equal to true when I'm counting the number of vowels, and vowels set equal to false when I'm counting the number of consonants. Let's run this all again. And I still have 5 vowels and 8 consonants. So what I've done is I've combined two methods into a single method, and I've used a boolean to decide which one it's doing. That boolean is what's making it either count vowels or either count consonants because of these if statements. So the important thing here is you notice that when I call it, I now have to put that true or false in there. If I try to omit this, it won't compile. Likewise, if I were to try doing this in the wrong order, like I were to try putting the false here and then the name, you'll notice that it's still unhappy. It underlined the whole thing and it said, that doesn't make any sense. What's required is a string and what you provided is a boolean. What's required is then a boolean and what you provided is a string. This doesn't make any sense. So this is not allowed. The order has to match with the formal parameters up in the method call. Alright, if you're wondering why these two things are underlined, anytime you're dealing with a boolean, you can simplify things. It's perfectly valid to say if the boolean is equal to true, but if it's equal to true, then that's the same thing as just saying the original boolean. And down here where it says equal to false, it says you can just simplify that to not whatever the boolean is, and that's simpler. Both of them are correct, it's just giving you a hint saying that you can omit either one. Okay, so hopefully that example clarifies that anytime you have a method that has more than one parameter, the order in which you give the parameters, the types of parameters you give, and the number of parameters you give must match whatever you put inside of the parentheses when you declare the method. Alright, okay, so back over to our slides, let's move on. Alright, so capturing return values. Anytime that you have a method that returns a value, like here we have public static int largest, which returns an int, then when you call it, you're probably going to want to capture the result. I did this in my code over here as well. This method returns an int because it counted how many things were in there. And each time I called it, you notice I did this. I said int num vowels is equal to the method. That's because when the method completes, it returns a value, and if I don't capture that into a variable down in main, it's just lost. So I can call this without getting this part on there, and that's valid code, it works, but I don't have the answer anymore because I never stored it anywhere. That's why I have this equals int, int num vowels equals the name of the method. And likewise equal num consonants. I'm storing the result that I got back from the method. Likewise over in the slide here, when they call largest, they're storing it in the largest one, the largest two, etc. Okay, so remember you're going to generally store the return value. Okay, so next up we're going to talk about default values in parameters. So remember over in Python you could do something like this. Def is valid date, and then it took in 3 parameters, a year, a month, and a day, and in each of these you put an equals and a value. So if the user didn't pass you a year, a month, or a day, then you just simply assumed that it was 2024 January 1st. And this is a really handy thing that Python allows you to do. But unfortunately, there's no direct equivalent in Java. There's no way you can say int a equals 4 and have it do stuff. So you can't really do that. What you're instead going to do is you're going to have more than one version of the method. So let's talk about this. This is called overloaded methods. And this is something Java does that Python doesn't do. So down here in main we have int answer1 is equal to do stuff, and we're passing it a 2, a 3, and a 4. And then you notice we call do stuff and we're passing it a 2 and a 3, and it's happy with this code, which doesn't seem to make sense because either it has 3 parameters or it has 2 parameters. How does it have both 3 parameters and 2 parameters? And that's done because we are overloading the method do stuff. An overloaded method is simply another definition of the same method that takes different parameters. So here we have public static int do stuff. The second one is also public static int do stuff. They're the same method name, and generally Java doesn't allow you to do this. The one time it allows you to do it is if you have 2 different parameters in the parameter list, in the formal parameter list. So in the first one we're taking in 2 integers. So it expects 2 integers. So this second call where I say do stuff 2, 3, that is going to match this method. But the third one, the other definition takes in 3 parameters, an A, a B, and a C, and that's what's going to match when you do this first call because you're passing it a 2, a 3, and a 4, which are 3 integers. Okay, so to be clear, same method, same return type, same public static, same method name, but different numbers of parameters in the parameter list makes it into a default method, an overloaded method. So you might be asking, well, how does this relate to default parameters? Well, look what's happening in the case where we don't pass a C. In this case, I'm assuming that the C is equal to 1, and I'm adding 1 to the A and B value. Whereas in the second version, I'm taking in the A, the B, and the C, and I'm adding them together. So effectively, this first version of the method is kind of like in Python if I had said A, B, C equals 1. I'm assuming that the C is equal to 1 here because I'm filling in the 1. I'm not using a C parameter. So this allows you to have effectively default values. You can have as many overloaded methods as you want, but the rule is that each overloaded method must have a different number of parameters, a different type of parameters, or a different order of parameters. So you could, for example, have one that takes in an int and a double, and then another one that takes in a double and an int. In this second one, notice that the order is different. The int was first here and then the double, whereas here the double is first and then the int. Another option would be to take in 2 ints, or take in 2 doubles, or take in a car. So in this case, there might be 5 overloaded methods that just have different parameters and do different things. So let's take an example of why you might ever want to do this in the real world. So let's imagine you want to divide 2 numbers. So you start off and you write a method called divide 2 numbers. It takes in 2 integers and you return A divided by B. The method returns a double because sometimes you don't divide 2 numbers evenly, they'll come out to a double. So this all seems very reasonable. I can certainly pass it 10 and 3 and it will return 3.333. But what happens if I wanted to pass it 10 and 3.1? Well, I can't do that right now because it's expecting 2 integers. So instead, what I would need to do, in this case, you see if I try to pass it 2 numbers that are with decimals, 2 doubles, Java's unhappy. Incompatible type, possible lossy conversion from double to int. So now I'm going to write another version of divide two numbers. This time it takes in a double A and a double B, and it simply returns A divided by B. So if I go back to the previous one, it took in an int A and an int B and returned A divided by B. Now I have a double A and a double B that returns A divided by B. So this gives me two versions of the same method, one that expects two integers and a different one that expects two doubles. As a matter of fact, I could go crazy and make a bunch of these. So this one takes in two ints, this takes an int and a double, this takes a double and an int, and this takes two doubles. They all do the same thing, but they allow me to have more than one version. So you can see that this overloaded method thing is a little bit more powerful than the Python ability, which is simply to just give a default value. Here I can actually have different orders of the parameters and it will know what to do with them. So you might be wondering, okay, but if I have four versions, I could have different code in each of them, right? And yes, you absolutely could have different code in each of them. This is slightly different than this because I'm having to convert one of them to a double to make sure it does floating point math. So how does it know which one to call? And the answer is it's based on the order, the type, and the number of the parameters. It matches the method that matches the most closely to the one that you called it with. So if we come back here and we have two versions, this is a try me which takes in an int, and this is a try me which takes in an int and a float. If I say result is equal to try me 25 4.32f, then it's going to call this one, which is x times y, because the 25 is an integer and this is a float, and since that matches an int and a float in that order, it calls this one. It will never call this one with this code unless I pass it just a single int. So it looks at the type of the parameters, the order of the parameters, and the number of the parameters, and it matches the one that matches. If none match, then it gives you a compiler error because it doesn't know which one to call. Okay, so we've one last thing to talk about here, which is passing parameters into methods in Java is done with what's called pass by value. So this will make perfect sense to you as you watch this. When you get to the next presentation, the next slideshow, we're going to revisit this because the rules are slightly different when we're dealing with an object. But let's take this example where we have a method called B, capital B, which takes in an int x. And inside of here it adds 9 to that x and then it prints out the x. So let's take a look and start tracing this from our int a down at the bottom here. So I'm going to use our little handy dandy whiteboard as we trace through this code. So first off, we're going to erase some of this stuff and we're going to take a look at what's going on. So the way that we do this is that we have what's called an activation stack. And we generally draw an activation stack like this, just as a big U. And then we have our main method down at the bottom. And then if we have any new methods, they get popped on top up above the main method. So let's start off at the beginning of main. And we're going to start off with a equals 42. So down in my main, I'm going to say a is equal to 42. And that's an a, not a 9. It looks like a 9. Oops. There we go. So a is equal to 42. At this point, we say print out a. Well, that's very obvious. It's just going to print out 42 on the screen. So here's our little screen over here. The next thing that happens is that we make a call to the method b, and we're going to pass it the value of a. So inside of the method b, there's a variable called x. And the way that we're going to represent this on our little stack is we have our call to b, and it has a variable called x, and that x is going to be given the value that was passed to it. Now in main, a was equal to 42 and we passed a to b. So the value 42 is filled in here and x is set equal to 42 because that's what happens when you call a method. So at this next statement, control is going to move up to here and we're going to do everything that b tells us to do. So in b, it tells us to add 9 to the value of x. Well, this is our value of x currently, it's 42, and when we add 9 to it, that's no longer going to be 42, it's going to be 51, because 42 and 9 is 51. So our x is now equal to 51. Then we print out x, and this indeed is going to print out 51 on the screen. At this point, we reach the closing curly brace of the method B. And what's going to happen here is that the method B is now done. So the way that we denote this over on our stack is that we effectively cross it out because it's no longer in use. So we say that's no longer there. Well, everything that was inside of B, including this x over here, is no longer here. This is gone. This x and its value is no longer in memory. When a method ends, everything about that method gets erased. And so it's not just that it's, crossed out like I did, it's literally just gone. That B method looks like it never happened. And down in our main method, we see that the next line tells us to print out the value of A, and that includes the A that was down here in main. And so when it prints out A, it's going to print out the value of A, which is 42. The point of this example is to show that even though we called B and we sent it A, the A in main was never changed. This A remains 42 before and after the call to here. Even though it got mapped to this X and that X got changed, nothing actually ever happened to the A. And the reason for this is because Java passes by value. So when it passed this parameter up to the method, it passed the value 42. It didn't actually pass the A variable. That's what we have down here. The A variable is completely independent and it's never going to be changed. What it passed was the current value of the A variable, which was the number 42. And the X, when it was created, was set equal to 42. So the X started off with the same value, but they're two completely separate variables in memory. One of them is in main, and one of them is in the B method, the X being in the B method. So then when we changed the X up in the B method, it had no effect on the A, because a value was passed to the B method, and we're only seeing the value in the B method, which means anything that happens in the B method is independent from what's happening in the A method. And so I'm just going to show you this in code just to prove this point. So I'm going to make another method here. So public static void. We'll call it do stuff, and it's going to take in an int x. Yeah, I probably shouldn't call it x, but this is do stuff, so it's pretty generic. So again, we're going to print out the value of x. We're going to change the value of x, so x plus equals 10, and then we're going to print out the value of x again, just so that we can see the changes inside of here. And just so that I know where I am, I'm going to say inside do stuff. And put a colon, and that's what I'm going to do on both of those print statements. Inside do stuff, printing the x. Alright, so down in main, I'm going to create an integer, which I'm going to call y, and I'm going to set it equal to 10, and then I'm going to do stuff with y. Okay, so, and then everything that's down below this, I'm going to comment out with a big comment like that. You do a slash star and a star slash to comment everything out. So the only thing that's going to run is what's visible here on the screen that's not commented out. When I run this, I'm going to say inside of do stuff I have 10, and then I have 20 because I added 10 to it, because that's what happened inside of do stuff. So I just want to prove a couple of things to you. So instead of passing in y, I'm just going to put in the number 10. So the y is now irrelevant, and the same exact thing happens. 10 is copied up into the x. The x is printed out, which prints out a 10. The x is incremented by 10, which makes it 20, and then the x is printed out again. And so it doesn't actually matter whether I pass the y or the actual value 10 in there. In both cases, it does the exact same thing. So changing this again, I'm just going to prove another thing to you, and this one's going to be a little bit more confusing even still. Matter of fact, I'm going to add another print statement, and this time I'm going to say in main the value of x. Okay, so now I'm going to ask you, think about this before I actually hit run. What do you think is going to happen? The x here is equal to 10. I send the x up to do stuff received in the 10, it prints out 10, I think that's non-controversial. It adds 10 to it, which makes it 20, and it prints out 20. That part is easy. The question is, what am I going to get down in main when I print this? Am I going to get 10, or am I going to get 20? Because I changed the value of x up here. Well, this is a very important detail, and the answer is I'm going to get 10. The x down here in main is completely independent from the x that's up here in do stuff. They're both called x, but they're completely separate from each other. And if I go over to my little diagram that we had, and I show you this, what happened here was in main I have one x, and that x is equal to 10. Then in method do stuff, I have another x, which starts off being equal to 10, and then becomes 20 when I add 10 to it, and then when this pops off the stack, we're back to the original x still being 10. It never changed. So even though it's the same variable name, Java understands that this x and this x are completely separate from each other. Very specifically, this x only exists from this opening curly brace to that closing curly brace. It only exists inside of here, and it is separate and independent from this x, which exists from here all the way down through the closing curly brace for main, which is down here. Now granted, this is all commented out, so it's a moot point, but this x exists only inside of main. So variables are local to their own methods by default. This is not true in Python. You have some different behavior in Python. In Java, this x only exists inside of this method, and it is 100% independent from this x down here. Furthermore, this passes the current value of x up here. So if I were to change the current value of x with an x++, let's say, it now is passing 11, and this x up in do stuff will start off as 11, become 21, become 21, and then this original x is still going to be 11 when I print it out. So I'm going to get 11 in do stuff, I'm going to get 11 and 21, and back in main I'm still at 11. So very important detail for you to understand that variables are local to their own method, they're initialized by a passing of a value, and then they stay that way. All of what I just described is true as long as we are passing primitive types. Primitive types are ints, longs, bytes, shorts, doubles, floats, chars, and booleans. Those are the primitive types. As long as it's a primitive type, everything I've just described is how things are passed. There are different rules when you're dealing with complex types, which we'll talk about in our next video. So, just in summary, in that last example, we called method b, passed an argument of a is an integer, b has a formal parameter x, which is given a copy of the value of a, and thus the changes to x have no effect on a in that example. Alright, and that completes our discussion of methods in Java. In the next video, we're going to talk about more complex types. So hope to see you then. Take care.